Hi, welcome everybody. My name is Tomasz Godzik, and I'm here to talk about the Metals LSP server. So there has been two talks about Metals already in Vim and Emacs, but I'm here to concentrate more on how we try to make Metals a more welcoming experience for new and experienced developers alike. So let me delve into that. So questions, you can ask questions in the chat or in the Slack channel. I'll try to answer if we have time at the end, or probably at the next week at the Q&A session. All right, why am I here? So I'm working at Virtus Lab, which is a company in Krakow, Poland, and we've been working with Scala for around 10 years now. So from the very beginning, we've been working with Scala, and obviously there's one organization that specifically deals greatly with, currently with Scala, which is the Scala Center. If you don't know, Scala Center is a not-for-profit organization at EPFL. It's focused on open source and education. It deals with multiple projects, including even the Scala compiler, SPT, Scala Free, BLOOP, and Metals. And since last year, we joined Scala Center as a contributor member, which means that we use our developers' time to work on projects for Scala Center. And since June last year, we're actually working on Metals. So it's currently a collaboration between Virtus Lab and Scala Center with a lot more of different contributors. So there's actually a lot of people that helped Metals become what it is today. Obviously, first person to mention is Olafur, who created what Metals is today. There's Gabriela, who did a lot of good core work on the Metals. There's Jorge, who worked heavily on BLOOP, is the main maintainer of BLOOP, and this is what we heavily use in Metals. There's Chris, who had a talk yesterday. You can check it out. He created the COC Metals plugin, and obviously there's loads of people who contributed, and I'm super thankful for what they did, and most of it was great work. And since tooling is a very difficult subject, I'm super amazed that there is actually so many contributors. Okay, so what is Metals? Metals is a Scala language server with rich IDE features. That is a mouthful, but let's concentrate on the language server part. So I want to mention what language server is so that everybody is up to date. And the language server protocol is a protocol that Microsoft is working on. It allows communication between editor and server, an LSP server. So from a user perspective, it allows for you to use your favorite language. In case of Metals, that's Scala, in your favorite editor, be it VS Code, Emacs theme, or even Eclipse. So those 6 we support. And to show quickly how it works, so we have a client editor. You might be typing some code and you want maybe to have some completion. You want to know if you write those 4 letters at the start, what we can have, what we can write that is sensible in terms of the program. So we send the completion request to the LSP server, which actually knows a lot about the language. So it calculates those completions and just sends them back to the editor. The editor knows how to present those information to the user and then how to apply it. This way, it's not the metals or any LSP server that needs to deal with presentation logic, but just the editor, which hugely decreases the amount of work that we actually need to do to support any particular language. That's just not only completions. There's loads of different features. The basic one being diagnostic, telling you what errors, warnings you have in your code. There's go to definition, hover. We support all of those that you see on the screen and almost everything in the spec. So there's also more actually that you can achieve with LSP. So there's something called extensions. Well, extensions are not part of the official specification, but they allow working within that specification. So we have worksheets, tree view, quick pick, slow task, those 4 different features are not included in LSP, and we are able to reuse LSP to support those. I'll talk about some of those later. Okay, so that was LSP, but LSP is not the only part of metals. It is not the only thing that we use in metals. There's also a very similar to LSP thing, the build server protocol. It was actually created at Scala Center, and it deals with how, with the build itself. So how to recognize what the code needs, what are the dependencies, what projects there are in the workspace. And obviously, we have a whole universe of build tools for Scala. There are the 6 here we support in metals. There's at least two that we know can also build Scala, and we're in the middle of that. So supporting all of those tools would be a nightmare to just have like integration for each of those written manually. Thanks to BLOOP, actually, we don't have to do that. So each of those build tools have an ability to generate JSON configuration files for BLOOP, either via plugins or it might be even a core functionality, like in case of Seed or Fury. And based on that JSON configuration, we are able to start up the server and let it serve our requests. We are able to ask about the build specification. So it's a very similar thing, but in case of metals, it is actually a communication between 2 servers. So there's an LSP server and there's the BSP server, which is in this case BLOOP. And for example, we have some piece of code, some file, but we don't know what project it is. So we'll send ask the BLOOP server which project this particular file belongs to. BLOOP knows all that based on the information that was generated from the build tools, and sends back information that is the project full, for example. But another thing, we don't actually know how to compile it in LSP, at least in metals. So we'll actually ask BLOOP to do that. So could you compile it? BLOOP will be happy to do that, and we'll send maybe some error report back to LSP server, which then can present it back to the editor, and the editor can show the diagnostics. So that's very quickly how LSP and BSP work, which is the core things that allow metals to function. But let's get to the core of my talk. So To build the community, we have to deal with pain points in the Scala ecosystem and how we use Scala. And there was a recent survey, the Scala developer survey, which showed a lot of those issues the developers and newcomers alike have when trying to write in Scala. So let's start with one of the simpler questions. So everybody knows that it's hard to hire new developers in Scala, and as you can see from the statistics, it's around 90% of people who answered the survey are using Scala more than a year, which means there's very little fresh blood in the ecosystem, in the Scala community. It could also mean that the new people are not that connected with the community yet, and they didn't have an option to even see the survey. But I think it also shows that even if we missed some people, we don't have that many new people. And it's important to make the community welcoming and make the experience easy for the beginners in order to have an ability to hire new developers. So another thing about that is that there was a question, where did you learn Scala? And most people learned via either written material, online courses, or on the job. And well, we have some really good material and some online courses that people can use. It's not for everybody. It's not something that everyone is able to do, to learn on their own. We need to have some kind of a backbone at the universities. And you can see only 6% of people learn Scala at the university, which is a really low percentage. It's probably mostly because people are learning Python, but I believe Scala can be much better learning vehicle for learning to program. And as you can see, there was another question: how are you using Scala? And mostly people working in companies or on their projects, and not that much people are using it as a teaching vehicle. But obviously, it's something that less people do. It's not that everybody teaches, but it's still, it shows a trend that we have, that people are not learning to program using Scala. They're not actually doing a whole lot at the beginning of their careers with Scala. So what we wanted to do, what I especially want to do in regards to methods, is to try to make it as easy as possible to get started with Scala. So a colleague of mine actually implemented this feature that whenever you open a workspace and we detect it's a Scala workspace, but we don't have any JDK anywhere to be found, then we suggest, hey, do you want it installed? Then we install it and it all works. So I think it's pretty great because it's really hard to explain to newcomers that when you are learning Scala, you first need to install Java. And I had multiple issues when I was trying to teach people, and we spent an hour on getting set up. And part of it was the JDK. There were some other issues, obviously, sometimes, but it was one of the bigger issues. Another thing that I think is useful for beginners is how we enable people to run and debug their programs. So we create those code lenses that you just click on and you're able to run any code you want. It's easy to notice, and you can also debug, so more experienced users can also use that option, use those code lenses. and maybe newcomers can, it can be easier for the newcomers to notice those features. Another thing that might be used for newcomers, and it is also useful for me when I'm writing some code in Metals, is worksheets. They were released in January, and they're pretty fast, snappy, and responsive. At the start, we had an issue actually with discovering that feature, because to have a worksheet, you need to create a file that ends with .worksheet.sc. And a lot of people were complaining that it's not easy to find. So we actually implemented this new feature that allows you to create any kind of new Scala file with a pre-filled template. And it's really easy to use. And it was a thing that we needed to do in order to make Metals more welcoming, easier to use. And this is a thing, I'm talking about it all the time, but it is a thing that we are concentrating on. So if anybody sees any issues with anything that we implemented, we would love to have that reported. Even like the silliest things, you might think they are silly, but in some cases we don't see that there's an issue. And if you report that, hey, this, when I click enter, this goes to a weird place. And if you report that, then we can realize that, for example, I got super used to how it was buggy and I just forgot about it. So it's super useful for us to get issues reported and then fix them, trying to make them less painful. Another thing I was recently working on is a way to create new projects. So we have those GA templates that are on GitHub. I created a way for everybody to be able to just write a new Scala project, and then what you need to do is choose one of the templates that we have available, or you can actually ask to discover more, which we automatically download from. There's a site with a list of those templates, and then you can choose that. And simple to use, it's still not merged into the main code base, but I wanted to present it so that you can see what we are aiming for. Okay, so there's also some new things not necessarily connected to Scala itself or Metals itself. There's a thing called GITPOD, which allows you to open very easily any project in any GitHub or GitLab repository. It uses ECLIPSE THEIA, which is an online IDE based on the Monaco editor, which means it will be very similar to VS Code. VS Code is also based on that Monaco editor. And it works actually with all of the VS Code plugins. You can go to this sample project I did. I'll show it in a bit. github.com/tgodezzik/metals-sample. And there's a link there you can click and it will open the workspace. It's a great opportunity to create learning setup in universities, at some trainings, because you just one-click it and actually optimize that repository so that when you open it, you don't actually have to do anything. The code is already compiled. We don't have to wrangle with any issues like JDK setup or anything, because it's already there. Obviously, Metals allows for automatic JDK setup, but still it's much easier to have a reproducible workspace that we can use anytime we want, and we can just link to for anybody in our course or in our class. So additional feature is that we can easily just merge any fixes in Metals, and we can deploy them. You can use them by just switching the version of the Metals language server, and they will be available as soon as you reload the workspace. So it is pretty cool, I think. Okay, so let's see how it goes. So there's this, I hope you can all see this web page. It's the GitHub repository that I created. You actually go here into this link. It starts, it needs to pull the Docker image and start them up. So it might take a minute or so, but you know, it's still, you can go grab a coffee and then come back and they'll all be set up. It all obviously depends on the load that GitPod has, and at some points it might be more difficult to get a workspace, but hey, here we go. Let's see, let's try to, so we are actually connecting here to BLOOP. Everything is connected. Metals is actually downloaded. Okay, let's see. Maybe let's start with the worksheets. The Docker images are a bit slower, I think, than local, but I guess it all depends on whether we actually, because it's all for free here. So anything, I doubt the support will be as great as with any, if you pay for a special workspace for yourself. But this works if you go to a main. See, as I said, it's a bit slower, but let's see if we can actually make it bug. So let's see if it's, okay, that's a bug. Okay, that's, we can remove that. Should be fixed. And can we run it? Yeah, actually it's run. So it actually didn't take that long to start the workspace. And I obviously have some special things I created here, but they're pretty reproducible. You can mostly just get that copied over to any repository you'd like and be able to have those pre-built, because the way it's actually done is that whenever you push something to master, you can enable GitPods to pre-build the images. So I did this to like a pre-built, and this is an image, we just started it up. But it's pretty nice, it works. You can even debug, let's hope it works. So yeah, so you can see there's threads, there's variables, there's arguments, there's a name. So this is working, that's cool. Okay, let's go back to the presentation. This demo worked. Okay, so there are more pain points in the daily work with Scala that especially hit experienced developers. Obviously, compile times are the biggest problem, but there's issues, people are having issues with missing implicits, debugging complex code, editing code even. So obviously with Metals, as you've seen yesterday, if you attended the talks, if you haven't attended the Emacs and Vim talks, then I recommend, if you're interested in any of that editing experience, you watch them. And so for anybody who is super unhappy with how their tool works, they can switch to another editor and it might be better for them. So that we give that alternative. So people will be able to just do what they want, use what the tool they want. Some other pain points is obvious SBT. There's, you can see INTELLIJ. You can, obviously SBT will be the biggest pain point because it's also the thing that is most used. So I think that's a bit of a correlation here. Some other things, build tool setup. A lot of people are having issues with that. Hopefully, because we support in Metals so many different build tools, people can just use whichever they want. A lot of people are saying about JDK setup, so that's also something we, I think we quite solved with Metals. The editor setup is pretty easy to get it all going in Metals. So I think that's we maybe not solved a lot of the pain points, but we are actively trying to address them. So previously, in one of the previous statistics, you've seen that long compile times are a big issue. So we, in Metals, we use BLOOP, which runs, actually, it's a server, so it runs we run a single server on any developer's machine. We can run multiple Metals instances, so you can open a lot of workspaces, and each of those will connect to that running BLOOP server, which is JITted, so it works all the time. It doesn't need to warm up. You don't have to have multiple Scala build servers. It's just this one. And we only compile for CLI. You can use BLOOP from CLI, and you can use BLOOP via Metals. And you only compile once. So the compilation is shared between those two places. In the future, we want to also make it, Jorge is actively working on making it possible to for SBT to use BLOOP, and this way there will be no recompilation needed. We would compile everything once and would be able to run tests easily via SBT or BLOOP or in Metals. And this, I think that helps immensely, because a lot of the problems with long compilation times are if you have to compile that many times. So long compilation times times n2, at least 2, is a big issue. Some other things you can try is BLOOP works with Hydra. So Hydra really helps out with the compilation times, and the guys behind it are actually trying their best to make everything work really good with BLOOP. And since it works with BLOOP, you can actually use that with Metals. Obviously, a lot of the people are using INTELLIJ for their daily coding. And while INTELLIJ is a really good solution, it has a lot of features and additional tooling, and it is probably one of the best things to use for Scala currently, but it's actually not for everyone. So INTELLIJ is not the only editor. It's not the only IDE. There's people using Visual Studio Code. There's people using Vim, and indexing times in a lot of the workspaces are really long. And if you want to just quickly edit some code, it's rather unpleasant to just start INTELLIJ and wait until everything's finished. And so I think, like, for a quicker experience, we can use Metals, and especially if you're new into Scala, you probably never use INTELLIJ. You probably use Visual Studio Code, and this could be an additional barrier for you if you are just starting. Another issue we raised was the build tool setup. As I said, we actually work with 6 of the build tools here. There's an active development on the PANT side. So Olafur is currently working on making the PANT setup working well inside both actually INTELLIJ and Metals. So we're doing that using the BSP protocol. There is some things going on the Bazel side, but I think that's the least supported. There's not, I haven't heard there was much success in regards to Bazel. So there's also an option. We actually have a PR ready for Ammonite scripts, and you'll be able to just create any workspace, create some Ammonite scripts, and you will not have to use any build tool. We are also thinking about maybe a really simple build tool, or rather a creator that would, you could specify all the dependencies you would like. or the name of the project, Scala version, and that would quickly generate an SBT, Gradle, Mail, whichever build you want. So that could be useful. We haven't started on that. It's still in idea phase. It's something I'm just thinking about, but I want to again say that we are trying to make everything as painless as possible. So, okay. And so another thing I was playing around with is optimizing local workspaces. So GitPod is one solution that you can use, but it's only online. It's might be a bit slower because you don't have any control over it. But we can actually create just a very similar thing with some Docker images where we compile the code and prepare all the indices. We can connect to any of those Docker images via Visual Studio Code SSH extension. And those Docker containers can be accessed via web, or we can even use some additional things like Kubernetes or ECLIPSE. ECLIPSE is a thing that is very concentrated on a workspace, online workspaces, and making it. It's a very complex thing, so maybe I will not delve into that. I recommend reading about it because it is very interesting. In essence, it tries to solve the issue with developers setup by making it super easy to create new workspaces for each person in your team. It is very connected to ECLIPSE THEIA, and because THEIA is one of the main editors, it's like a front end for ECLIPSE. Not the only one, but one of. So let's try a demo. Hopefully this also works. Let's say I created the image previously, and I can just run it. So that's the image I created. I need to check the port because I haven't automated it. Okay, that's this port. Let's see, there's this SSH extension somewhere. If I find it, yes, here. So I actually have that. Let me see. Yeah, I need to fix one thing, and we can connect to that. Yeah, there's a very advanced password here. And okay, that's set up. Let's open a folder. That's method sample. Okay, it's the same project we had. So that is locally. I haven't figured out why it's trying to download some stuff still, but we have worksheets here. They're being evaluated. Everything being, yeah. So this is working. We have the main method. We can maybe check if everything's still working. Oh, we can run. That's working. We can debug. So that is running inside a Docker image I created previously. You didn't have to import anything. The only startup was Metals indexing, but Metals indexing on compiled workspaces is pretty fast. We just need to load some stuff into a memory for that, not that much things, and yeah, I think it's working pretty well. Everything seems to work without an issue, so it's pretty cool that we can have those workspaces deployed anywhere, and people can just connect them. Maybe even like for one developer, it could also be useful. So if you have a very good desktop computer that with a lot of RAM and stuff, you can just easily connect to that and have a really good experience, even from outside your home. So I think that's a pretty good thing to enhance your editing experience. It all works with metals because of the VS Code extension. So you can install the VS Code extension on that machine that you are connecting to. I installed it here before while creating the image. So there's a lot of stuff you can do to optimize how you create the images, and that is still a bit work in progress. Okay, so that worked. The last of the big pain points a lot of people are having issues with is the Scala-free migration. So we're talking about like tooling support. We're talking about tooling support that people are worried there will not be enough tooling support. The migration costs will be great. The syntax will be weird. But I'm happy to say that we already have the support. PR with a support ready for Scala-free in metals. There is support in INTELLIJ. We're working on with Scala Center on making a lot of the tools that people use for Scala 2 also available for Scala-free. There's really large effort on making the transition as smooth as possible. The first PR we have in metals is quite basic, I would say. The experience is still really good, but we don't have some custom completions that are normally implemented for metals, but they will be coming soon. We'll make sure that everything we had in Scala 2 support will be included in the Scala 3 support. And we'll make sure that we'll be testing out that metals works well for both Scala 2 and Scala 3 all the time. And there will probably be some additional features that will be implemented for Scala 3, but that will be in the future. But I'm pretty excited about playing around with the new things. Okay, and actually, I think Scala 3 brings to the table a lot of new fun concepts that make it more accessible, like the optional breaks, which I personally don't hate, and because it's much cleaner for people coming from Python and much more understandable, I would say. It might not be to everybody's taste, but I think it is very good for growing the community. There's explicit nulls, which are pretty amazing things for even experienced developers. So you can be sure if any variable or value is a null. It's already like that in TypeScript and in Kotlin, and this is a thing that I would urge you to check out. There's outer methods, so you no longer have to create some objects, and you can just create some methods and annotate with main, and you can see that actually looks pretty amazing. You don't have to have an array of strings. You can have different parameters, and yeah, I think that's pretty great. There's extension methods which look much better, for me at least. I'm pretty excited about that. And there's even more stuff, and all of that I believe will be great for making sure that Scala is still does still a lot of modern features, innovate, and people will be able to start with it easier. And for example, there's simplified pattern matching. So the unapplies are completely different now, done completely differently. There's better macros. You cannot break your code. There's enums. They're really focusing. The people behind DOTI are really focusing so that the migration is quite easy. The people were there was at some point there was people in the survey said that implicit resolution is a problem, and I checked it out in DOTI, and you actually get suggestions. Hey, maybe you want to import it from here. So I think it's pretty great. And since I'm running out of time slowly, I want to talk about maybe some recent work. There were some, in January, new features merged. We have the run and debug. We added the total implementation, which finds all the implementations of a method, rename symbol, some new code action, and the worksheet support, which you have seen previously. There's new things coming soon. So there's the go to parent code lenses, which I think is amazing for navigation of your code. They allow you to basically go either to the direct parent of any method you are overriding, or actually you can use the shortcut and see the whole hierarchy of methods. We'll have a better support for large main methods and tests. It will not only be via code lenses, but you'll be able to define it yourself by just writing the name of the method or a test class. We're working on Ammonite script support. There's a PR that we are actively working on. And there'll be support for Scala 3. I'm planning to work on merging that PR next week. So there might be some thing to test out under snapshot versions very soon. If you are interested in our future work, you can go to the Metals feature request repository and vote on any issues you would like to see, and also create some issue requests so that you can say that, hey, I want that in Metals, could you implement it? Okay, so there's some links here. You can, if you have any questions now, I don't know if we have time. My stopper says 3 minutes, maybe? 7 minutes, yes. 7 minutes, okay. Probably should have stopped the timer before. Okay, so there was a last year's presentation on Scala Days by Olafur. I highly encourage you to see that. My presentation is available at slides.com/TomaszGodzik/growing. You can actually check that out also in the Slack channel. If you're interested in metals, you should take a look at the metals documentation. There's also interesting stuff. It's really nice to read about BLOOP because you'll get a better understanding how it's all working together, and I think that's pretty useful. But yeah, that's mostly it. I probably made it more faster than I anticipated, but if you have any questions, please ask now or on the Slack channel.
Thank you very much for a great talk. I was wondering if you can elaborate a little bit about why currently with Bazel it's not fully supported yet.
We don't have like first of all, in metals, we have automatic support for any build tools we for sure know are working with BLOOP and metals. So if we detect it's that workspace, then we just suggest that you can import the build. For Bazel, I'm following a issue in on Bazel. I think that's Bazel rules or something like that. But any case, there's no like complete example of how to work with Bazel and BLOOP because it's a bit complicated to make it work in really large workspaces. So the work we're doing with pants, for example, a lot of that work has to do with large code bases. So the Bazel support will also need to deal with large code bases. Bazel is mostly used for large code bases, and that is still like making sure that metals and BLOOP, all that works together in large code bases. That's an ongoing work. And from I checked last, it's not that easy to import a Bazel build to use with metals.
Well, I currently use Bazel in INTELLIJ, and I just load the parts of the repo that I'm currently working on. So that's the issue of large repos is solved there.
Yes, but that's with the INTELLIJ integration. With the BLOOP integration, we're not there yet.
Okay, thank you.
Okay. Yeah. Oh, run and debug with Play Framework. There was a question about whether there's a way to run and debug with Play Framework. I still need to check because I actually did a release yesterday. So we added this support for launch JSON in VS Code, but that is not only useful for VS Code because we also added this support for just sending, executing a command with very simple parameters, and you get a URI for the DAP client, so debug adapter client. So it's very useful for any Vim Spectre. It can be used for a Vim Spectre. It can be useful for Emacs, the DAP client. So that can be very useful. And I think with Play, we might be able to run it using that, but I still have to find that out. But I think like the question, I answered the question mostly that you can just run SBT in the background. And I think it's the quickest to do, just do SBT, run with the tilde, I'm not sure the name, but that you can run it inside VS Code, for example, and it's fine. And every time you do anything in Metals, it will recompile. That will be probably much better once we have the support for offloading to BLOOP from SBT. So in the future, hopefully not too far future, because like a lot of the elements are there, we'll have an ability to have everything compile via BLOOP. So it will be super nice for like editor. So you write something in the editor, and then it compiles in BLOOP. SBT also use BLOOP, so it deduplicates the compilation. So basically, it's much faster workflow. But that is, I think Jorge is still working on that, on making it stable. Not sure about the estimates since he needs to be the one who takes a look at it. I don't think anybody has the deep knowledge of BLOOP to make it happen except him, and he's not doing that full time now. So I think he's doing that in his own time. So we cannot pressure any timeline there. Yeah. So also I said we did the new releases today. There's a couple of new features. Some small features. We wanted to do the release before the Scala 3 support is merged into Metals, because that is a lot of changes and pretty scary changes. I'm pretty confident about them, but for to make sure everything's working, we'll merge it into master and let it sit in master for a while, so that people who use snapshots can figure out whether the maybe the Scala 2 support deteriorated, or maybe the Scala 3 is not yet working super cool. So I was testing it, everything seemed fine, but you cannot test everything every time. So but I think I wanted to merge the Scala 3 support this week, but I didn't manage to, and I think that will be next week. But yeah, I think like last comments that were posted by Olafur, pretty much all of them are fixed. So I think we should be fine with merging that basic support. So.
Great. What was the biggest challenge, to arrange the support of Scala 3?
I think the biggest challenge was to make everything in SBT, and for me especially, I'm not an SBT.
Yeah, exactly. For you, yeah.
But the biggest challenge was because I learned actually mostly I was doing the changes to SBT. I was doing small changes and not like going crazy about doing the whole build, working over the whole build structure. But now I needed to make sure everything's working fine. And I think another big issue was like testing. Tests. We wanted to make sure that we have like proper testing for DOTI, for Scala 3, and that also connects with the SBT specification, like the SBT configuration. So, but after some iterations on it and some helpful comments from Olaf, I think we managed to get it working pretty well.
I have a question about BLOOP, Tomasz, that maybe you can answer, because I feel like a lot of times when people ask about running their code or testing their code, the response that they get is, yeah, just use SBT tilde and like watch your changes. Is there a benefit instead of doing that to just use BLOOP directly with the watch flag, so then you can reuse compilations and you don't need to worry about SBT?
Yeah, you can do that. My response previously was to the play server, running the play server. I'm not sure we can run it with BLOOP. If we can run it with BLOOP, we can most likely run it with metals, but I haven't yet checked that. That's why I responded with the thing. I know that you can run it with tilde, but yeah, you're right. If you run anything else, any main class that is defined in the code, that I know that works for sure, and it's better to probably just use the watch in BLOOP CLI because it will be the exact same compilation as in metals itself. So from what I know, checked, and I was comparing with INTELLIJ and seeing how it works, and I think it's much faster, and we managed to get it all working pretty quick, because there's no compilation. you can there's one compilation, and I think that's I think that's faster. And with SBT you will have the double compilation, so that's not that great. It will be an incremental compilation for sure, so it most likely won't be anything super slow, because SBT, both SBT and BLOOP uses Zinc underneath, but it will be much better to just run BLOOP if you don't have any specific SBT magic going on.
Cool, thanks.
Yeah, if anyone is interested in any new features, I mean, we want to do a lot. There's plenty. But we're still open to having people come and create feature requests. It might be some small things that are actually easier to implement. So we might be actually more inclined to do them because we can do it fast, and there's more value than doing this really large thing and having a minimum value added. So yeah, I recommend raising issues also with any bugs you can see, because otherwise they might get lost and never fixed. And we try to respond to everything. So sometimes we cannot fix it that fast, but if it's the smaller the bug, the high probability we can fix it fast, especially things with completions and with presentation compiler. They're actually super fast and quite fun to fix.
What set of libraries you use?
We mostly use the Scala Meta stack, because metals itself is based on the Scala Meta, mostly on semantic DB, because it's the thing we use for references. We use MUnit, which is the testing framework also inside the Scala Meta organization. We do use a lot of Lee Howey's libraries because they're awesome. And also we use metals. At least I use metals to develop metals so that I find the bugs first.
Are you trying to use Scala semantic DB for other than Scala, or only Scala?
Like semantic DB mostly has the support for Scala. I don't think there was any work done on any other languages, but the format is like supposed to be interlanguage, so it should be possible to create like additional compiler plugins for different languages, or especially like the DOTI support for semantic DB is baked into the compiler itself. So it isn't actually that difficult to get it working, especially like because semantic DB itself is done using the protobuf library. So it has like interfaces for different languages.
Mm-hmm.
Like it should be doable for other languages. I don't think there's any initiative to do that though.
One question: are they user as a programmer which work on tools? What do you think? How different will be experience of programmer within 5 or 10 years? What will change it in our?
Hopefully the tooling is much better, especially for Scala. Another hope I have is that maybe Scala is more used for data science, because like Python is really, I like Python, but I don't think for large complicated programs like big data science, it's actually that good to use it. And maybe in 5 to 10 years, we'll manage to get the Scala native properly supported with some nice bindings, or even different set of libraries that are useful for data science. What else could be different? Hopefully, less JavaScript in the world. Like TypeScript is awesome. Everybody should use just TypeScript. And so that's another hope I have.
I have a question.
Mm-hmm.
Why you decided to be involved in such project as Metal? What was your motivation?
So I work at Virtus Lab, and we are cooperating with Scala Center, and actually this came up as one of the options we could pursue, like as a part of our collaboration. And it actually, when we looked at the code and at everything, it actually seemed a pretty awesome project. So mostly because there was an opportunity from Scala Center to do that. And second, it was actually a pretty cool project, so we were super happy to do it. So
thank you. Thank you.
Thanks for the question.
I've checked the Metal website, and I can't find IDEA integration.
That's a more complicated subject, because there are some plugins, but they're not that perfect, and they're not official plugins from JetBrains. So if there was an official plugin from JetBrains, we would most likely try to support it, but I don't think they're planning on it, because maybe I heard some rumors that maybe some languages might have support via LSP, but I haven't heard on like a proper LSP support in INTELLIJ, and especially that INTELLIJ has a great Scala support already using just the Scala plugin. We don't focus on it at all, because like you can just use the Scala plugin with INTELLIJ. That is not the case with Vim or VS Code, so it's like a totally different. We focus on making those experiences better, because like JetBrains is working on the experience for INTELLIJ. And yeah, we do have some common work, like especially a lot of people are working on BSP, and BSP both works with Metal and with INTELLIJ. So there's some common work going on with BLOOP there. So that part is when we do some work on BLOOP, it will also benefit people using BSP with INTELLIJ. But as far as the Scala language support is, how the work around it looks, it's we don't do any kind of work together, and we don't we don't plan on supporting metals for sure for INTELLIJ, at least until there's a proper plugin. And I don't think they plan to do a proper plugin for it. Yeah, and especially the difference that we use the Scala presentation compiler. So and they have I think a separate fork. So if they were using the Scala presentation compiler, there would be some benefit to us working on some fixes to the Scala presentation compiler, but unfortunately, that's not the case. I guess maybe there's some fixes coming to the fork, but I'm not sure how it's all working together.
And could you compare maturity of Metal and INTELLIJ? So how to explain to my colleague whether Metal worth to use?
The maturity of metals in comparison to INTELLIJ?
Yeah.
Right. I mean, I think for most features, we have them implemented, though some of it, especially debugging, is much better in INTELLIJ currently. Though I think the whole ecosystem when using Metal is a bit faster, but it's more snappy. So and you don't the setup is much quicker because we only have one build server, so the code is compiled via that build server, and you start up different. I sometimes have 4 or 5 different projects, some of them big, and that's still working. While with INTELLIJ, it's very hard to have that working on even I have on my computer 16 gigabytes of RAM. It still would be very hard, and especially the bigger the workspace, the harder it is to have anything else running. So, as I was saying on my presentation, INTELLIJ provides much more tools overall, and with Scala, there are some things we don't yet support. For example, the implicit, we don't show the implicit yet, but that's planned. Overall, the biggest difference is while they provide more features and it's more feature complete, we do have a more snappy, faster development setup that people can use. They can use it together with INTELLIJ. They can use INTELLIJ for some big projects that they have some hardcore debugging to do. And they can also use Metal to quickly edit some smaller projects that they're working on. I know that some people are using both solutions depending on what they need at the moment.
Thank you
so it's not, yeah, you can actually install INTELLIJ shortcuts on VS Code, for example. So a lot of that is the same experience.
Thank you very much. Thank you.
Thanks. Thank you. Thank you for the questions and for the conference.